welcome to Pre-Calculus. In this video we're going to do 10-7 polar coordinates. This is going to finish off this section. So to convert between these old rectangular coordinates and our new polar coordinates, it's pretty simple. To establish a relationship between polar and rectangular, let the polar axis coincide with the positive x, the pole with the origin as shown in the figure. Because x comma y lies on a circle of radius r, it follows, here's our old circle formula, x squared plus y squared equals r squared. Or you might remember back in chapter 4, section 4, when we were doing the trig values of any angle, we saw this, r equals root x squared plus y squared. And then these might look familiar also from section 4-4. Cos is the x-coordinate divided by r, sine is the y-coordinate divided by r, and tan is y over x. And we actually used this not too long ago in another section. So we've already established these from previous sections, so what we're going to do is just manipulate those around a little bit. Ooh, and let me back up here. So for this one, if I want to get x alone, I would multiply both sides by r over 1, so these r's would cancel, and now there's an r over here. X is r times the cos of theta. Same thing here, I could multiply this side by r, and I would have y equals r times the sine of theta. So here, the polar coordinates are theta, and the rectangular coordinates xy are related like this. If you're got polar and you want to go rectangular, your x is r times the cos of your angle. The y is r times the sine of your angle. If we want to go from rectangular back to polar, we know that tangent is y over x, and here we have our circle, x squared plus y squared equals r squared. So let's just dive in and give it a go. In example 3, polar to rectangular, our r value is root 3. Our theta is 0.6. So I'm going to just write that here. R is root 3. Theta equals pi over 6. So I'm going to do my x-coordinate here in red. X is equal to r times the cos of theta. And in blue, I'll do my y. Y is equal to r times sine theta. So let's see here. Our r value is root 3, and then we're going to do the cos of pi over 6. Well, the cos of pi over 6 is root 3 over 2. So I want to multiply. My numerator is root 3 times root 3. That's going to be root 9, or 3, divided by 2. So there's my x value. Let's find our y. Y is equal to r is root 3, times the sine of pi over 6. The sine of pi over 6 is a half. So here's my root 3. We're going to multiply that by a half. So my y value is root 3 in the numerator, 2 in the denominator. So what we did here, our polar coordinates were root 3, comma pi over 6, polar. And then we converted that into something we could graph in the rectangular system. That would be 3/2, comma root 3 over 2. Those are our rectangular coordinates. What does this look like graphically? Like that. Again, for the rectangular, over 3/2, up root 3 over 2 takes us to this point. The other way to get there would be our distance from the origin is root 3, and the angle that would take us to that trajectory is our pi 6. So again, here's our polar converted to our rectangular. Now in example 4, we're going the other way, rectangular to polar. So let's, if we remember right here, tan is y over x, and then we have sort of our circle, x squared plus y squared equals r squared. So I'm going to write tan theta equals y over x. And over here, we're going to do r equals x squared plus y squared under a radical. And let's note here, if we're in a rectangular coordinate and we go -1, +1, we're definitely going to be in quadrant 2 here. So our tan of theta equals y is 1, x is negative 1, 1 over negative 1. So our tan value is equal to negative 1. And where does that happen? If we look at our unit circle, in quadrant 2, that's going to be at the angle 3/4 pi. Now, if we come over here to find our r value, underneath my radical, my x is a negative 1 that I'm going to square. My y value is a positive 1 that I'm going to square. So that's going to be 1 plus 1 under the radical. And last I checked, that adds up to a 2 under the radical. So I'm going to do this here in the middle. Here's our rectangular system. Coordinates, negative 1, 1. If we want to graph it in the polar method, it would be root 2, comma, 3/4 pi. All right, now it's time for you to practice. Convert the first one to rectangular. Convert the second one to polar. I'm going to put these on their own slides. So pause the video, give them a try, fire it up, and see what you got. All right, in the first one here, x is our cos theta, y is our sine theta. So x, our r value is 2, and then we're going to do the cos of pi radians. The cos of pi is negative 1. So that's going to be 2 times negative 1, which is negative 2. Now our y-coordinate is r, which is 2, times the sine of pi, and the sine of pi is 0. So this is 2 times 0, and that's equal to 0. So our old coordinates were 2 comma pi under the polar. Our rectangular coordinates would be negative 2 comma 0. Next one, we've got rectangular, and we want to convert into polar. So we need to know that tan of theta is y over x, and r is the root of x squared plus y squared. So over here, tan of theta, our y value is 2, and our x value is 0. Uh-oh. Remember, when we are dividing by 0, our tangent value is undefined. So over here, let's go to, and then if we look at our unit circle, where is tangent undefined? Well, it's undefined at pi over 2, and also at 3 pi over 2. But let's think about here our coordinate. If we graph that on the rectangular system, 0 comma 2 would be right here on the positive y-axis. So we want to probably use the pi over 2 for our theta, for our angle. All right, now our r value, r is equal to root, our x is 0, so 0 squared, plus 2 squared. So that'll be 0 plus 4, and the square root of 4 is equal to 2. So under the rectangular system, we are at 0 comma 2. Under the polar system, it would be 2 comma pi over 2. Okay, now we're going to convert entire equations, not just coordinates. Some of these are really simple. Some of them, they're going to make you think. So the book says to convert a rectangular equation to polar, replace the x with r cos theta, replace the y with r sine theta. That's not too difficult. But then simplifying it after that might lead to a little trouble. For example, here's how to write the equation y equals x squared in polar form. Well, here's y. We can turn that to r times sine theta. And we can turn x squared into r cos theta quantity squared. And then sine is, we could divide both sides by sine. So over here we'll have a cos over sine. Well, I'm going to write it out over here. R sine theta equals, when we square this, we'll have an r squared, and we'll have a cos squared. So if we divide both sides by r, These will cancel, and this will be down to r to the first power. So now we're going to divide both sides by cos squared. So our r value is going to be sine over cos squared, or sine over cos times 1 over cos. This sine over cos turns into tan. 1 over cos turns into secant. Okay, let's check out these. We got part A, B, and C here in our last example. Convert from polar to rectangular. The graph of the polar equation. So our polar equation is simple as r equals 2. This consists of all points that are 2 units from the pole. In other words, the graph is a circle centered at the origin of radius 2. Confirm this by convert to rectangular form and then use the relationship. Here's our old circle equation. X squared plus y squared equals the radius squared. So if r is equal to 2, then r squared would equal 2 squared, also known as 4. And then we know from here that x squared plus y squared is equal to r squared. Well, our r squared is 4, so we could write x squared plus y squared equals 4. Again, that is just the equation of a circle. This is our radius squared. So what we have is a circle centered at the origin of radius 2. Again, our polar equation is just r equals 2. Here it is in the rectangular form for a circle. Okay, 5b. The graph of the polar equation, I'm going to write it here. Theta equals pi over 3. That's our polar equation. Consists of all points on the line that makes an angle of pi 3 with the polar axis. Convert to rectangular form using the relationship tan equals y over x. Tan theta equals y over x. Well, here's our polar equation. Theta equals pi over 3. And then I know the tan of theta, or the tan of pi over 3. I would just go to the unit circle and see that's equal to root 3. Well, now I'm going to take out this tan and replace it with y over x. So y over x is equal to the root of 3. And then if we solve to get y by itself, we're just going to multiply both sides by x, multiply by x, y equals root 3x. This is our rectangular form of that equation. It is just a line. Remember, y equals mx plus b. So in this case, we know the slope is root 3, and our y-intercept would be a 0. So that's just a graph going through the origin with the slope of square root 3. Okay, part C, last of the example. The graph of the polar equation, r equals secant theta, r equals secant theta, is not evident by inspection, so convert to rectangular form, and we're going to use this relationship. X equals r cos theta. I'm going to just write it over here. Oop, that's ugly cos. Write it over here for safekeeping. So r is equal to secant. Well, remember, secant, its reciprocal identity is 1 over cos x. And if I multiply here both sides by cos, I'm going to multiply by cos here so they cancel. And this r is going to get multiplied by cos theta. So over here, all I have left is a 1. So r cos theta equals 1. Well, I'm going to turn this r cos theta into a 1. X equals 1 is our rectangular equivalent of r equals secant theta. And what that looks like is just a vertical line. X equals 1, here's 1 on the x-axis, we would have a vertical line. Okay, now I say pause the video and try these 3. A and B are not bad, they're very similar to what we did in the example, but this part C is kind of a juicy one. So if you don't get that one on your own, don't feel bad. Pause the video, give them a try. Okay, I'm going to put these over here for safekeeping real quick. The first one's pretty simple. It's just like part A of the example. Circle of radius 7. So r equals 7 is our polar. So we would square both sides. R squared equals 7 squared, and that's 49. And then back in that example, they said we could use the relationship x squared plus y squared is equal to r squared. Well, r squared is 49. So this will be x squared plus y squared equals 7 squared, or 49. Again, this is just a circle centered at the origin, radius of 7. Letter B. This is a line, just like we saw here, with the tangent equal to y over x. It's going to be very, very similar. So our theta is equal to pi over 4. And then the tan of theta, or the tan of pi over 4, that's equal to 1. And then we know that tan of theta is y over x. So we're going to turn this tangent into a 1. 1 is equal to y over x. If I want to get y alone, I would multiply both sides by x. So y is equal to x. Or to put it in slope-intercept form, y equals 1x plus 0. So there's we started with our polar, and here's our line. Okay, now for the juicy one, the extra juicy one. R equals 6 sine theta. So R equals 6 sine theta is our rectangular. And we know that sine of theta is equal to y over r. So I'm going to take out this sine theta, and I'm going to replace that. So this 6, I'm going to put it as 6 over 1. Sine of theta is y over r. Now, if I multiply both sides by r to clear this denominator, over here, r times r is r squared. So now we have r squared equals 6 times y. And remember, x squared plus y squared is equal to r squared. So I'm going to come up here, and I'm going to do x squared plus y squared is equal to, I'm going to take out the r squared and replace it with this 6y. Boom. Now here's where I got stuck originally on this, and this is going to be a throwback to chapter P. Let's get everything on one side so it's equal to 0. X squared plus y squared, we're going to subtract this, so it's minus 6y. Now it's equal to 0, and maybe you see where this is heading. We're going to have to complete the square on this component right here. So I'm going to come down in red ink and do a little complete the square. We'll bring down the y, we'll bring down the minus. Half of 6 is 3. And when we bounce back up, we would square that. So we're going to add 9 to the left side. We got to be fair and add 9 to the right side. So this is going to equal 9 over here. And then I'm just going to bring down this x squared. X squared plus quantity y minus 3, quantity squared, equals 9. Remember, I could, on this x, put in x plus 0 squared plus y minus 3 squared equals, I'm going to rewrite the 9 as 3 squared. So this is just a circle. The center of our circle is 0, comma, positive 3, and the radius is equal to 3. So we got a circle of radius 3 at this center. Oh, that was a good one. So here's a little summary. Explain how to plot the point. Oh, no, it's not a summary. It's just you sort of explaining stuff. The homework is on WebAssign. In class, we'll do some odd problems to solidify these topics. I hope the video was helpful.